What's going on YouTube? Today we're doing under construction, which is part of the beginner track. So if you click on under construction to read the description, a company that specializes in web development is creating a new site that's currently under construction. Can you obtain the flag? So we have an instance to connect to and we have files to download. So you can download the files and start the instance. Let's go to the virtual machine. Upon downloading the files, we inspect the files now. So we go to desktop. Okay, making this bigger. So upon downloading the files, as you can see, we have a zipped file. We unzip the file, we receive these files: helpers, middleware, routes, package, index. Now for public key and token, these files I have created them while I was doing the challenge, so never mind these for now. So let's take a look at the index.js. Okay, and we see that this file, as you can see, the extension is JS and is written with the Express framework in Node.js. If we scroll down, we have endpoints here such as /routes. If you scroll down, take a look at other routes. So nothing indeed in this file other than some rules about the listening port and handling the 404 pages. Let's now inspect the routes. CD routes. So let's take a look at the index.js file that's called under routes. Again, we see the Express framework, and here we see another call for helpers, JWT helper and DB helper, and another call to middleware, authentication middleware. So we have to take a look at all of these three paths. So let's scroll down and see here we see the route to the home page, and it's using the authentication middleware. So here it checks on the username, whether the username exists on the database or not. This check is performed in the authentication middleware, and if you scroll down, we see endpoints such as authentication page, the logout, and the handling of the authentication process. Okay, so we see this one here. The check is performed on the database if the username exists on the database or not. As you can see, it uses the DB helper, which we will check out in a bit, and based on that it throws an error if the username already exists, or if it doesn't exist you have to register and you get successfully registered. So let's take a look now at the Oauth middleware, okay, that handles the username check. JWT helper. Seems like we're dealing with JWT tokens. So we take a look at first middleware. Okay, so this is the module JWT helper. So again, Oauth middleware is using the JWT helper, and it seems that it is the token, or the JWT token, is actually combined with the cookie to check on the user status. Scrolling down, so that's what it does. It checks on the JWT. Now if you go back and go to helpers, taking a look at the file that is handling the tokens, as you can see, it's using the library JSON web token, and this library has a vulnerability that I'm going to tell you about, guys. So basically it uses private key and public key. Previously, if you watched my videos about JWT exploitation, we used to gets the secret key. So it was like sort of symmetric encryption, right? So we have a symmetric key in a set of public and private key to encode the token. This time we have private and public key asymmetric encryption. Now let's take a look at this bulletin here. As you can see, the JSON Web Token library. JSON Web Token is a JSON Web Token implementation for symmetric and asymmetric keys. In this case, guys, we're dealing with asymmetric keys because we have private and public key. Okay. Affected versions of this package are vulnerable to an authentication bypass attack due to the algorithm not being enforced. Attackers are given the opportunity to choose the algorithm sent to the server and generate signatures with arbitrary contents. This means we can craft our own tokens with our own usernames and our own algorithms. The server expects an RSA asymmetric key, but instead is sent an HMAC SHA-1, right? So we have to send an HMAC key instead of the RSA with our choosing of the username. Okay, so now we understand what we need to do. We need to exploit the vulnerability in JSON Web Token implementation. So instead of RSA, we're gonna send the HS256 and we're gonna select a username of our choosing. Okay, so this is for the JSON Web Token. Let's take a look at the database now. This is the file handling the database. So it's SQLite 3. This is good information. And if you scroll down here, we see the check on the username. As you can see, the username field is directly used inside a query. So this is the username field without any input sanitization, which means we can use SQL injection. So here you have it, guys. First, exploit JSON Web Token, generate a token, and use SQL injection to display all users. So instead of focusing or aiming on a single username by which we will generate a fake token, we will use the fact that there is no sanitization on the username field and use SQL injection payloads to generate fake tokens. Okay, let's see how this process goes. So this is the site. I'm going to show you this in a minute. Okay, so I'm going to turn Purpose Suite off. It's off now. I'm going to log out, and that's what you see when you first access the site. Now we can register with a single username. Let's go to register. Test 3. Register. Okay, registration is successful. Now we can log in. Log in. Message from developers. Welcome, test 3. This site is under development. This will come back later. Now, since we saw in the source code that there is some sort of JWT tokens, let's take a look at the tokens and see if they are combined with the cookie or not. So inspect, going to storage, and here we see the value of the JWT token, as you can see, which is a value, happens to be the value of the cookie. So we can go to this site, JSON Web Tokens, paste in, copy that, paste it here, and we see the algorithm. It's RS256 as we saw in the source code, and here is the public key, and this is the username. Of course, the username will change because this is the old username when I first did the challenge. Let's copy this one, copy that. As you can see, the user now is test3, and this is the public key. Okay, now what we need to do, guys, we need to copy the public key, okay, from here, store it in a file, and we're going to use a tool to create a fake token. So this is the tool from GitHub. As you can see, it's called the JSON Web Token Toolkit version 2. This tool is a tremendously important tool to perform testing, scanning, and exploitation for all implementation of JSON Web Tokens. You can simply clone the repository and install the requirements with this command. Okay, cloning the repository with this command and installing the requirements with this command. and all the way down you can see the workflow. So here we do the recon, here we do the scanning, and we do the exploitation. Now, since beforehand we know that it is vulnerable to the confusion attack or the JSON Web Token confusion attack, we're going to skip the recon and the scanning, and we're going to head right to the exploitation. As you can see, we need to supply the JSON Web Token with a couple of options. I'm going to walk you through these options in a bit. Okay, so closing this now, no need for this. Okay, going back now to the terminal. Okay, so let's first cd back. We're going to need to create a new public key, guys, instead of the old ones. Okay, so here I'm going to store the public key. I take the public key from here, so copy that, and here we're going to perform several modifications to make sure the format is correct. So the first thing, we're gonna put a new line here, remove the \n, looking for all \n's here. As you can see, this is one. We're gonna remove this one and create a new line. Here we have one \n, remove this, enter new line, one \n, enter new line, another \n, enter new line, and this is it. Nope, we have still one here, and another one, and lastly remove the last \n, enter new line, and here last \n, enter new line. So to make sure that we got the public key correctly, we're gonna copy the public key, and we're gonna scroll down. As you can see, the signature is verified. So normally the token is signed with the public key. If the public key is incorrect, it will give the signature not verified or invalid signature. If you see, if I remove the public key from here, from the verified signature, it's telling me the signature is invalid. If I paste the public key that I have formatted, as you can see, the public key is correct and the signature is verified, which means that the server will use this public key to verify the token. So we're gonna save this. So I have the public key here. Now I need the token. So the token can be, if you go back, log out. So let's register a new user. Turn on intercept. And here let's say test 5, test 5. Register. This is the request. We're gonna forward the request. Again, forward. So registration has been performed successfully. Test 5 to log in. Test 5 login. Okay, so forward, and this is the token, guys. So we're gonna copy this one, RM token, nano token, paste the token here. Okay, now one last thing, we need to send this request to the repeater. Why? Because we will create several tokens throughout the exploitation process, so we don't need to send an intercept request every time. So we're gonna highlight this, click on send to repeater. Okay, forward this, no need anymore, and this is the request. Here we're gonna tamper with the JSON Web Token. Okay then. So going back here, to the terminal. And here, guys, I'm going to clear all of that, and in a single tab I'm going to execute the tool, cd tools. No such file. What the shit, man? Oh, okay. So Python 3. So what do we have in here? Not found. Did you mean? Okay. Let's take a look at the help menu. So to craft the command, we have to understand the help menu, guys. The first thing we will supply the file containing the token. You can supply the token as is, no need to specify any option. You can specify the URL -t, but for this scenario you don't need to do that. Scrolling down, since we know that the application is vulnerable, we're gonna use the option -x to tell the tool that we want to exploit the server, and we're gonna select here the mode of the exploit. We have several modes. We have A for algorithm none. We have talked about this before. We have for null signature, blank password, spoofing the token, and lastly we have the K. The K is key confusion, which is the case of today's challenge. So the challenge of the token is vulnerable to key confusion attack, which means we can, with the public key, we have the public key, we can craft a token and confuse the server that we have the correct signature. So we will use the public key instead of the private key to convince the server that the public key is the secret key. So we use -k, -xi, scrolling down, no need to sign. Private key, we don't have private key. -t, we're going to use -t as well to make sure that we tamper with the token. -i to inject, and -pc. -pc indicate that what we would like to inject, or what we would like to tamper. In this case, we are tampering with the username. -pv, the payload. The payload will be the SQL injection payload. Okay. So let me show you guys the command. Not this tab, I guess this one. Okay. So I launch the tool, and then I use a subshell. Okay. Just to display the contents of the token. You don't need to do this as well. You can just place the content of the token in a bare format. -i, as I said earlier, to inject. -pc, here we specify the field that we would like to inject. In this case, it's username. -p, here we put the content of the payload. Okay. And lastly, we define the public key using -pk. -xk, the injection mode is confusion attack. Okay, let's now play with the payload. Let's first try with a single payload to make sure, or to verify that the generated token works. So let's see with test 6. In this case, I am telling the tool to generate a JSON web token to log in or use the username test6. File not found. Okay, so here we need to change this to, let's see here. Okay, so the file name is keepup. Okay, so here keepup. So we have generated a new token now. Let's take this token and try with it. So users test6 doesn't exist in our database. So this means, guys, that we were able to successfully execute a fake token on the server. I know that the user doesn't exist, but that's not important. It doesn't matter. More importantly, we were able to generate a token that matches that user. So what we're going to do next, we're going to use union select SQL payloads. So in the payload, we're going to change this single quote, and then we're going to select one of the SQL injection payloads. Let's search for union. So we have them here. So let's take and 1 equals 0 union all select. Okay, and from here we have to find out the number of columns. Okay, let's start with 2. Okay, once we get an error, we stop incrementing the number of columns. So let's start with 1. Let's see here. Yeah. And generate the token. Error, SQL error, select to the left and right of union all don't have the same number of columns. Okay, let's increase them to 1. And there is something we got. So welcome 1, which means, guys, the correct number of columns is 3. So we have to work with the 3 columns right now. Now we can start injecting or calling values from the database. Our objective is to reveal the flag, so definitely the flag is stored in the database. Okay, let's first get the version of the database. Okay, and we hit enter. We copy the new token. Scrolling down, so the version is 3.30.1. This is the version of the database. Now it's time to reveal the tables. So revealing the tables now. We're going to use the group concat. So we reveal the table names. We hit send. SQLite error, no such column table name. Going back, let's check our payload. So I think we forgot to specify the database. So the table will be selected from a database, right? So here we're going to write from which is the default database, SQLite master. Let's try with this one. In other scenarios, it could be different name of database. I have to find this out. Unrecognized token. So we didn't put a space here. trying now. Let's see here. So welcome flag storage SQLite sequence users. So here we got all of the tables. Now it's time, guys, to reveal all of the columns under these tables. We can do that by revealing the contents of the SQL database. So the same thing here. We're going to choose SQL. Take the new token. Send. Okay, so as you can see, flag storage table does have two columns, top secret underscore flag with double A in the flag. Again, we have SQLite sequence table with username and password columns, and this is it. So now we can reveal the contents of the flag, guys. It's going to be pretty easy. So we go back, and here we're going to change the name of the table. So instead of SQLite master, we're going to choose flag storage. And in the group concat, we're going to reveal the content of the flag. Let's see if this will work, hopefully. And we hit send. And here you got this, guys. This is the flag. Let's see if the flag is correct, you know. Make sure we don't hit a rabbit hole. This is the page of the token. No need for this one. Submit a flag. And it's correct. So what else we can do, guys, in this challenge? Let's go back. I see previously I saw password and username. Let me go back to another request, the previous one, this one. Copy that. So there is another table, as you can see, SQLite sequence with username and password in it. So let's reveal the username and the password. So here it will be SQLite sequence. And here username. I just want to see the username first. No such column username. Well, let's go back to the previous request. So username, password, SQLite sequence. I guess these are the table is users. Let's try with users. I want to see if there's any chance that there is an admin user. So welcome user, test 1, test 3, test 5. So there is no admin user. All of these are the users that I have registered myself. So this is it, guys. I hope you liked the video and found it useful, and I will definitely, guys, see you in the next one.